We will start by taking a static measurement of the capacitance. This can be taken to be the theoretical value of the capacitance, and the uncertainty in this theoretical value is the least count of the capacitance meter. It's in microfarads. The following is a resistance box with resistors R and 2R. Do not take the values R and 2R to be literal. We'll measure them separately. Here's the resistance R. And here's the resistance 2R. Observe that the scale has shifted to mega ohms. It's possible to get a different resistance by hooking up R and 2R in series. I've done that using this banana cable by shorting these two terminals. So let's find the resistance of R and 2R in series. The scale is once again in mega ohms. Lastly, we can also find them in parallel. I've shorted these two terminals with a banana cable and those two terminals with a banana cable, and all I would need to do is to measure the resistance between any of these terminals and any of those terminals. We are back to kilo ohms. This is the fully assembled RC circuit. You can see the power supply there, supplying current through the current limiting resistor here. Resistor R is in action now. It goes through the capacitor. Now, of course, current cannot flow through a capacitor because it's a gap between two plates, so I have temporarily shorted the plates of the capacitor with this shorting wire. And because of that, current does flow through this ammeter, known as a Simpson ammeter. The needle here is resting at the 25 microampere scale. So there are several scales here, and the one you need to read is this thing here. Between the red and the mirror, there are three black readings. You have to take the middle of those three black readings. And so the middle one starts at 0 here, it's 10 here, it's 20 here, it's 30 here, 40 and 50. So just to be clear, we are looking at that middle reading. I will now remove the capacitor short. You can start your stopwatch and find the time taken for it to go from 25 to 20. Repeat this 3 times. Now we'll take the time needed to go from 25 to 15. I'm going over a little each time, so you need to stop your stopwatch before the end of the segment. Next, I'm going from 25 to 10. I'll go a little under 10. finally I'll go from 25 to 5. This will take the longest time. I have next connected the resistor to R. Because the resistance is high, the power supply is not able to provide more than 20 microamperes through this system. I will only do this once, and the purpose of this particular run of experiment is to determine the time constant from the time taken for the current to go to 37% of its value. So mentally calculate what 37% of 20 is, and I will make it go up to 5 just for safety. Next, we'll be looking at R and 2R connected in series. This has the biggest resistance, and so the current is even smaller. It's about 13.5 microamperes. I will try to let it go down to about 40% of its value, which is around 4. For the last experiment, I have R and 2R in parallel. This combination has got the least amount of resistance, so it's pretty easy to bring the ammeter back to 25 microamperes. But this time, the needle is going to come down very swiftly because the time constant is also going to be very small. For this reason, I will do this experiment 3 times, so you can in each case, you will yourself calculate what 37% of the time is and find the time taken to go up to that point. Don't rely on when I stop my switch.